So this is the natural response for the three cases, for underdamping, critical damping, and overdamping. If I have two distinguished root, so which means I have just add another constant, which basic about my root of my characteristic equations. If my root they are equals, that's the I need to add a little bit to change in my formula. But if my root is complex when I have the j imaginary, so I end up with the sine and cosine. The reason why just there is the relation between sine and cosine and exponential part, guys, if you remember. So sine x can be written as e os jx plus e os minus jx divided by 2. That's the relation. So that's why cosine part comes here. But it's still starting point from the cosine, still exponential part. It's still natural response. And this one I am doubt we can cover it in Monday if I have time. But today we're gonna cover the first case. And Friday, or we're gonna start with the second case. Let's see a first example here. So the first example, generally speaking, you look at the circuit and you identify the order before you start. In this circuit here, we have one inductors, one capacitors. That's enough judgment to your final equations. It should be second order differential equation. That's the first point. The second point, what ask me to find, look at my initial conditions. Since I have two parameters, so I need two initial conditions instead of one, because I have two unknown parameters. So I have here's the I of L, the current inductor through the inductors, and first derivative for inductors. That's the second part. From your initial conditions, so here I ask you to find the characteristic equations and the root of the circuit in figure below. Now I have IL, this is my X1, and what am my X2? I have VC or I have IS. So my X2 will be IS. So I need to finalize my differential equations. It should be the current through the capacitors and current source. So that's our target here. We need to write down the equations that related between IL and IS. The third one, the starting point from your any differential equations, put in front of your two equations. The first one, the voltage across the inductors. We know this one is the L multiplied by d IL by dt. That's the first equation you keep it in your mind before you start. The second one, I look for the current through the capacitors, IC, which will be C, first derivative of the voltage of the capacitors, VC divided by dt. Those two equations, you keep it in your mind before you start. Now you can start in any way or method you know. The only thing you keep it in your mind, for example, if I use the nodal analysis, here I assume is V here, I cannot say V minus L or minus C divided by something. You cannot. Dealing with the inductors and capacitors, the only way you deal with those two equations, nothing else. Okay. So let's see how to solve this problem, guys. Solving the problem means write the second derivative equations that controlled by IL and IS. What do you think? I can solve it in two methods. One method, okay, I can find the current through the resistors, basically equal the IS minus IL. And this the current times 40, give me the voltage. Or I can solve the second one. I have here is the current source parallel with the resistance. I can use source transformations. Source transformations. So in that case, my circuit, I will use source transformations. In that case, if you want to choose different method, that's totally fine. You want to compare the result. But the source transformations, I converted my current source to the voltage source. And that voltage source value, it is just 40 divided by IS. Then series with the resistance 40, and then my inductors, and then my capacitors. So now I have the series connection. So this one is the L, this one is the C, and this one is the R, which will be 40, and this one 40 IS. Again, I don't touch the current here. Here is still IL, and here is still VC. Question with that, guys? Now I go back to write down the Kirchhoff voltage law. Kirchhoff voltage law. We're gonna start from here. I have negative to positive, right? So this one is the minus 40 IS plus the current times R plus R times the current. Current, I will call it IL plus what? Plus voltage across the inductors. What the voltage across the inductors? I go back for my equations here. This one should be L di L divided by dt plus VC. This quantity equals 0. Question with that? Now let's go back for our equations. We mentioned we need IL and IS. I have IS, I have IL, I have IL here, first derivative. I have VC. So I need to get rid of from the VC from the equations, and I write it in a function with the IL. How I can do that, guys? Any guess? Okay, series connections. What that mean? I have IL. Since I have one current through my series resistors, I have IL equal IC. Everybody agree with that?
Yeah.
Great. Now, let's go for the IC. Where is the IC? So that means equal C dV by dt. You agree with that? So now IL equal D C dV by dC. You agree with that? But now what I am looking for the VC, not the first derivative of the VC. Right? So what I can do? What the opposite of the derivative?
Integral.
Integral. Okay, so what I'm gonna do? I'm gonna make the integral for those two parts. So integral of IL dt, and this one is equal C is constant, integral of dV by dt dt. You agree with that? So what I end up with these equations here? I end up with the dv, or what I'm looking for. I'm looking for the vc, right? Yes, I'm looking for here the vc, right? So the integral or the derivative, they want to cancel each other. So I end up with the vc and I need to divide by c. So this one will be 1 over c integral of I L of t dt. That's my equations that I needed to finish my derivative equations. You agree with that? Now let's write down our equations, first derivative, or the equation, the starting with. I'm gonna take 40 minus 40 to the second part. So I end up with the R times IL plus L DIL divided by dt plus 1 over c integral IL of t and dt. And this the entire quantity here equal 40 IS. Where is 40? It's the R. Agree with that? Anyone has any question? Okay, now we're gonna use my operators. D by dt, I will use S. Integral, I will use 1 over S. So just rewrite down my equation. Okay, gonna be 40 IL, and follow me guys if you make 40 IL. There is no derivative. The second term will be LS, and L how much? 100 milli. So this one is 100 power to the minus 3 S. This one is S, guys. IL. The third part, the integration, right? 1 over C. See how much is it? 1 over third. So this one is going to be 3. This one 1 over S, guys. So let's write down in the different way. Let's type, just keep it numerical value at the last part. So here's the RIL plus SL times IL plus 1 over C times S, in this case of the integral, times IL. And this one will be the second part is just, it is R, something happened in my computer, R times IS. That's my equation as the symbolic form. So now just plug the number inside the equations here, what we end up. And I will take the IL out from my equation as a common factor. So here is that gonna be 40 plus S times L will be 100 milli S plus I have 1 over third, so which would be 3 times to the power 3, because 1 over S because of 1 over S. And the entire 1 times IL equal 40 IS. Agree with that?
Yes.
Agree with that. So now the only thing we end up with the 1S, but don't forget we have S in the denominators here. We need to multiply the entire equation with the S. So what we end up, you end up with the 40S plus, here is the 100 power to the minus 3. S times this will be S squared plus 3 times, or the power to the 3 with no S here. And this one, the entirety times IL. And this one will be 40 SIS. Question with that? No question? Okay. Now we're gonna go back for the formula that we listed in the first step. We need to S square times by 1, and we need the parameter for the S times by 2 alpha, and the the absolute value, it is omega 0 squared. So I just rewrite it again, or just divide it here by the 100 milli and simplify this the circuit. I end up with the S squared plus 400S plus 3 4 zeros. Yes, 4 zeros. That's absolute value. And this one's then the entirely will be 400S. So our characteristic equations, this characteristic equations, what are you looking for? Which means S squared plus 400 S plus 30,000 equal 0. This is my characteristic equations. What we have? 2 alpha, remember guys, 2 alpha. Here is the alpha will be 200. Be 400 divided by 2. Because the entire, this one will be 2 alpha. It's 400 divided by 2. So it should be 200. And omega 0 square, this one will be 30,000. Now I need to find the roots based on my characteristic equations here. But again, for the equation, quick reminder, this is the equation I'm looking for. S1 will be minus alpha, plus or minus. That's if you want to do it. S1 minus alpha. I have alpha is 200 minus 200. Somebody prepare the calculation, guys. 200. I will take a plus first one, root square of alpha square. Alpha square mean 200 square minus omega square. I have minus 30,000. So here is going to be 400, 10,000, right? So it's going to be 100. So this one will be minus 100. Confirm that, guys. And S2 going to be the same thing, but I will subtract this one. So it's going to be minus 200 minus 100. So I end up with the minus 300. Confirm that, guys, if I did any mistake, but I think it's straightforward. No. Question with that. Now, if I go back for my 3 cases, I end up with the 2 distinct real. So I have minus 100 and minus 300. So this is my situations. So my xn in this case is my current A E os the S1T is minus 100 T plus, you can call it B E os second one is minus 300 minus 300 T. So this is my natural response. So the only thing missing now, I need to find A and B. But this equation don't ask us to find the questions for the A and B. We're gonna keep it for next question with that. So if we look at this method here, the starting point, it is very important one. The way that you start your problem, that's to make it your solution easy or not. Because once you write down these equations here, you are basically done. So just implement the number, find the characteristic equations, find your response. So what you need to do, start, be careful to solve the problem. You don't have to jump, or you can do it very fast. Spend the time with the first part. Question with that? So our measure right now to find the differential equation between Vs and V of t. Okay. And replace everything else and show up in our equation. Let's start. I will use nodal analysis, guys. And just be careful again. Nodal analysis, the first one, V divided by R. Current cross this one, right? Plus the current through the capacitors, right? The current through the capacitors. I have this form here, C dVc by dt. Plus this confusing part, plus what? Any guess? Any guess, guys? Dealing with the inductors, I have volt, I don't have I, right? If you look at the form that I start with, how I can deal with that case? So basically what we are looking for nodal analysis, you're looking for the current. So here is the current, that his value, this value, here is the current, comes out, its value V divided by R, and the same thing, here is the current IL, guys. So the only thing I can keep it like this, IL. Okay, so this one should be IL, and this equals here. Oh, okay, now we end up with the equations V, and so this one is VC and V, they are the same, so can replace this one V. And I have IL, and I don't have VS in my equations. How I can deal with that? Look at guys here. If I draw it in the easy way, here is I have the inductors. I have the inductors here. And here I have the source. I draw just the left side of my circuit. Okay, this is one L, and this is one is the VC. And this what this value here? What this one? It's volt, right? Or V, right? Am I right?
Yeah.
So what's the V? V gonna be equal the voltage across the capacitor and the inductor, sorry, and the voltage here, the VC. Add them together, give me the volt. So here I can write volt or V equal volts across the inductors will be L DIL by dt plus VC or VS, sorry. VS. This one what we need in that case. But now I'm looking for my equations here. I'm looking for the IL. Here I have first derivative. I can deal with that. So from these equations here, I can see V minus, or let's make it further, 1 over L, V minus Vs equal first derivative for my current. Agree with that? And just take the Vs second part and divide by L. So I have first derivative for I, and I'm looking for I, not first derivative. What we did last time? Integral. So I have here is the 1 over L integral my V minus V dt. And this one is the integral of first derivative of the current, the I by dt. So I can write down 1 over L integral V minus Vs dt equal IL. That's the equation missing from my part. This is the equations that we are looking for. So this one here, I have to replace it in my equations here. Anyone has any question or any confusing point? So now the rest, we just you apply your equations here, put in these equations, and replace your operators and numerical value. Let me do it in. Do you want to do it, or just give you the operator formula? So here is the operating formula, and after we put the operations, the operator, sorry. C times V plus V over R and plus our 1 over this one from the integration part, 1 over S times L. So this is our characteristic equations. Just we needed to do it in the right way. So I have S here. I have to multiply it. So I end up with the equations here. L C squared plus L over R times S. L over R. I multiply the equation for SL. Times LS plus 1, and this is the entire one times V. Question with that? Now to confirm this equation with our characteristic equation before, we need to divide by LS to keep just S squared. So after divide by LS, I end up with the S squared plus I divide by L, so L cancel with the L. So I end up 1 over RC times S plus I divide by this one, 1 over LC. This one is equal 0. Plug the number, guys. R and C. What we have for the value for the R and C, 80 times 200 micros. So Can somebody confirm this one, how much the value it is? It's 1 for the 80 times 25. Well, here's 1,000. We just micro, so I raise this one to the top. So 1 million divided by this value, guys. Somebody get for me. And 1 over LC what L, how much? L 1 Henry, right? Yeah, it is 1 Henry. Okay, so basically 1 over C. So we have C 1 over 1 times 25 micro power to the minus 6. So basically 1,000,025, how much would be? Power to the 6 divided by 25. Anyone has those two values? 1 over RC, how much?
I got 500.
500. We can take 500. And this one, million times 20 divided by 25. Something starts with the 4.
40,000.
40,000. 40,000 as a value. Okay, great. So now our characteristic equation is square plus 500 is plus 40,000 equals 0. Now my alpha will be 250, right? Just 500 divided by 2, 250. Our omega 0 square, it will be 40,000. So now our S1 equal minus alpha plus root square of alpha square minus omega square. And this will be minus 250 plus root square of 250 square minus 40,000. Okay, calculate this me how much. And similarly, S2 will be minus alpha. The only difference in the root square part, minus root square of my alpha square minus omega 2 square.
Wouldn't it be 16,000?
Did you take the root square?
Because it's 4 times 40,000.
What are you talking about? This one?
It'd be under the square root, 250 squared minus 4 times 40,000.
How much you got?
I haven't got the full answer. I'm just still writing it out.
Okay. Then the value that you got 16 or something, take the root square, I think, right?
Yeah, it's squared. You just
Yeah.
have to multiply it by the 4.
I don't know what the 4 came from. Where's the 4 came from?
The quadratic equation.
No. No, nothing to do with.
Oh, we don't have to do the quadratic for that?
This one, see? This is the format you're looking for. Because you already
Okay.
simplified. The 2 here to
Okay.
A, that's where it came from the 2 alpha.
Okay,
There is no root square, yes.
okay.
Okay. V of 0, which in this case equal, this one equals 6 or 0, guys? 6?
Yeah, 6.
6, right? Yes. So this one is equal 6. Equal, I have to replace my t equals 0 in my equations here. What we end up with? 0 gonna be 1, 0 gonna be 1. Here is the A plus B equals 6. This is my equations number 1. You can make it easy. You can take it A or B, either one. A equals 6 minus B. Second one here, guys, I have this first one. I cannot find my value from one initial condition. That's why I need second initial condition to find another equations. So my second equation is here, dv by dt, and add 0 here. That should be minus 30,000. What I gonna do, I can first derivative for this equations and then take t equals 0. Okay, so basically what that means, minus 100 times a e os minus 100, and this one 0. Just want to type it. Second one, minus 400 times b e os minus 400 and 0. So what I end up with this equations here, exponential will be cancelled because of 0. So I end up with minus 3,000 equal minus 100a minus 400b. Cancel my negative with negative with negative. So I end up with the 100a plus 400b equal 3,000. 3,000, not 30,000, right? I can cancel 2 zeros from here, 2 zeros and 2 zeros. So which means the a plus 4b, just to make it easy, 4b equal 30. And this is my second equations. Now I can solve. Now I can find my a and b's. I take the a, 6 minus b, remove a, so this one will be, if I remove that with me, here is the 6 minus b plus 4, b equal 30. 6 with this one will be 24, right? And minus b plus the 4b will be 3b. So from here, b will be 8. Go back for this one, 8. And a, it should be minus 2. Confirm the number, guys, if I made mistake. Now, I can write my natural response for the voltage of the capacitors with its value. A should be minus 2, exponential minus 100t, plus 8 e os minus 400t. That's my equations. That's my natural response for the voltage across the capacitor in my circuit.